Hello and welcome to the next session of model number 4 centroid. In the previous sessions we had discussed various numericals of different shapes. So, initially we had discussed or tried to locate the centroid of various composite sections, and next we had to remove a part from the given lamina and try to locate the centroid. In the continuation with the same, let us move further. So, the problem goes like this: find the centroid of the shaded area as shown in figure. So, we have to find the centroid of the shaded area. The figure is like this. This is 32 mm, the radius of semicircle is 12 mm, this width is given as 8 mm, and this height is given as 12 mm, and this particular height is given as 4 mm. So, as you can see, which is the shaded region? So, this whatever I have shaded is the shaded region, and this is an opening made. The remaining part is the shaded area. We have to locate the centroid of this shaded area. As I said earlier, if we had considered this as the shaded region without an opening, then the location of centroid would have been at a different place, and when we considered it as an opening or we remove this part, then the centroid will be located at a different place. Okay? Now, so what are the steps involved in calculating the centroid or locating the centroid? The very first step is look into any axis of symmetry. Do you have any axis of symmetry? If you draw an axis exactly here, so it cuts into two different mirror images. That is, one part is equal to the other part. One part is equal to the mirror image of the other. So, you can say this is a axis of symmetry. Okay? And they have not specified any reference axis. So, it is up to you to choose the reference axis. Clear? So, since it is symmetrical about y axis, x bar will be equal to 0, given that you choose the referral axis also along this line, then only we can say x bar is 0. But if you choose the reference axis to some point, then you need to consider x bar value, because the main criteria to measure the x bar is the reference axis. Okay? So, please be careful. Let me write the axis. reference axis or the coordinate axis. Let this be point O. So, now we can see OX and OY. If you continue this axis, we can also call this axis as axis YY, YY axis about which it is symmetrical. Okay. So, this also means that the centroid of this lamina lies somewhere along this line. Okay. So, if you have chosen this as an origin, therefore, the x bar value will be equal to 0. Clear? Now, let us divide this into known components, because you do not know the centroid of this lamina. Do you know any formula for this? No, we do not have any formula for an composite section of this kind. So, we know only regular geometrical figures. Okay. So, we shall divide this into number of known components. Say this semicircle be component 1, and let me name A, B, C and the midpoint of semicircle BD. Then let me name it as E, F, G should not be used, H and I. This is a rectangle, and now so this rectangle will be component 2. Now, coming to this region, we have two more parts. So, if I divide this by drawing a line, so this portion will be a triangle component 3 and this portion rectangle will be component 4. Let me name J, K, L, M and N. So, this is again for your convenience. You can proceed without naming all these things. So, what is the first step? The component 1. What is component 1? It is a semicircle. Semicircle and the radius is 12. That means this is 12 mm and this is also 12 mm. And it is A, B, C and D. And we know where does the centroid of this component lie, because it is a semicircle. It lies exactly along this line where it is symmetric about, and we have only y bar. There is no x bar as it is symmetrical about its axis, y axis. So, now this y bar is nothing but 4r by 3 pi. So, let me write only y component of this, it is 4r by 3 pi. So, what about area? Pi r square by 2 semicircle, that is equal to pi into 12 square by 2. Let it be as it is, we shall substitute it later. So, this will be mm square. Next, what about y? Y is equal to 4r by 3 pi. So, substitute r as 12, 4 into 12 by 3 pi. Okay. So, this is 226.15 mm square. I am writing this value now itself. Now, let us go to component 2. So, component 2 is rectangle. E, F, H and I. So, the dimensions of this rectangle are, is it given? Yes, it is given 16 mm. I had missed out writing the 16 mm. So, this is 16 mm and the total height is 32 mm. Where does the centroid of the rectangle lie? It exactly lies at center. So, I will be having both its x component and y component. See, again I want to tell you that these x and y are the centroidal values of individual components. Okay. So, A2 will be equal to 16 into 32, which is equal to 512 mm square, and x is equal to 16 by 2, which is 8 mm, y is equal to 32 by 2, which is equal to 16 mm. So, this is with respect to component 1 and component 2, and if you observe in the figure, component 1 and 2 are the shaded regions or shaded area, but component 3 and 4 are not shaded. That means what? It has to be removed out from that part. That means the area of component 3 and the area of component 4 should be deducted, and it should be written with a minus sign. Okay? Now, let us write the component 3 and 4 details. Component 3 is a triangle of base 8 mm and height 4 mm. So, it is triangle JKL. So, where does the centroid of a triangle lie, which we have already derived it? Here it is along this line where the y bar will be located, and this will be the location of the centroid of a triangle, and this will be its y component, which will be equal to what? B by 3 or h by 3? It is h by 3, which we had already derived. And why are we not writing x? Because it is symmetrical about this axis. That is why no x component should be written. Now, what is the area of triangle? A3 half into base into height. Okay. So, that has to be written with a minus sign, negative sign, because it is to be removed. That is minus 16 mm square coming to its y component. Y component is equal to h by 3, that is 4 by 3, which is equal to 1.33 mm. Do not write y with a minus sign, we are not writing any negative sign for y. Now, component 4. Component 4. So, component 4 is again a rectangle K, L, M, N, and it is 8 mm by 12 mm. So, where does the centroid of a rectangle lie? It exactly lies at center. So, therefore, we can easily write its x component and y component. So, now let us calculate area A4, which is equal to x dimension into y dimension, that is 8 mm into 12 mm with a minus sign, which is equal to minus 96 mm square, and its x component is half of 8 and its y component is half of 12. So, what I will be doing here is, let me write a star because minus sign should be included, okay, because those parts have to be removed out. Okay. So, now once we are done with the calculations of the individual components, let us try to put it on the referral axis and then try to measure it with respect to the referral axis. Clear? Now, let me write the table. Component area in mm square x bar in mm with respect to OY axis, y bar in mm with respect to OX axis, and we have to write a statement before writing the table, that is the lamina is symmetrical about YY axis. Therefore, what is 0? X bar is equal to 0. So, if x bar is 0, the entire column will be 0. Okay? You just need to enter the y bar components. So, component 1 is semicircle A, B, C, D. So, area of this semicircle pi r square by 2, that is 226.15 mm square. X bar is absent or 0 and y bar is, see, we had tried to locate the y bar of the individual component here. The centroid of this semicircle can be located here, but it has to be measured with respect to the reference axis or the coordinate axis. So, this distance is nothing but our y1. So, what is y1 equal to? It is this distance plus 4r by 3 pi, that is, so the distance from this point to this point is 32 mm. 32 plus 4 into 12 by 3 pi is equal to 37.09. So, this is the value of y1. Second component is the rectangle EF HI. So, this is the rectangular component. 16 into 32 is 512 mm square. There is no x component, and let us try to locate its y component. So, exactly at center, say somewhere here, this is nothing but y2. So, y2 is nothing but half of 32. mm. Third component is the triangle JKL. Area of the triangle half into base into height, half into 8 into 4, which is 16 mm square. And what about y3? From the previous step, we know the centroid of this rectangle lies somewhere here, but it has to be measured with respect to the referral axis. So, this distance will be equal to y3. We had tried to locate only this, but measure it from this end. So, that will be y3, that is 12 mm plus h by 3, that is 4 by 3, that is equal to 13.33 mm. So, are we missing anything or can I proceed to the next step? I have missed writing minus sign here, and the last component is 4, that is the rectangle KLMN. So, the area of this rectangle is 8 mm by 12 mm, that is 96 mm square, and since it is also an opening, we shall write the minus sign here, and there is no x component. Try to locate the y component. So, for y component of this rectangle is exactly at center. Try to measure this with respect to the reference axis, which is y 4. This is nothing but half of 12. mm. Now, our table is complete. Using this table, what we can do is we can substitute the values of y1, y2, y3, y4 to calculate the y bar. So, we have the formula, that is y bar is equal to a1 y1 plus a2 y2 plus a3 y3 plus a4 y4 divided by a1 plus a2 plus a3 plus a4. See, I am not writing the minus sign here itself because that might create a confusion. So, write it as it is, then substitute the value as it is. So, that is a1. What is a1? 226.15 into y1 37.09 plus what is a2? 512 into 16, then plus a3 is minus 16 into y3 13.33 plus a4 is minus 96 into y4 is 6 whole divided by 226.15 plus 512 plus minus 16 plus minus 96 in brackets. So, this is how you are going to substitute the values of the negative areas. Okay. So, now after substituting, you can write the y bar equals to .4 mm. So, the x bar is 0, y bar is 25.4 mm. I hope you have understood this. So, we are left out with the last step, that is the centroid of this lamina is equal to 0, 25.4 mm. Now, try to locate this in the actual figure, that is x is 0. So, along this line, what is y? Y is equal to 25.4. So, you have 32, 25 might be somewhere here. So, this is our g of x bar y bar. So, this is our centroidal axis xx, and along the same line we have this axis yy. Okay. See, it is a very simple one. Since it was symmetrical about the yy axis, we did not calculate x bar because it is 0, and that can be taken as a hint to choose the reference axis, so that this calculation of x bar is not required, but if you shift the reference axis to some other point, then you need to write the value of x bar. Please be careful with that. Okay? Understood? So, next let us move on to the next problem. Find the centroid of the shaded area shown in figure, and the figure is so this is the shaded region. This is 100 mm, this is 100 mm. It is having two components, one is a semicircle and one is a quadrant of a circle. So, you need to remove a semicircle from a quadrant of a circle. See, this is a quadrant of a circle, out of which you have to remove this semicircle and try to locate its centroid. Okay. So, this is a very simple problem. Now, let me divide this into two components, the quadrant B number 1, the semicircle B component number 2. What is the first step? Do you have any axis of symmetry? No. Then we can go for the next step, which is choosing the reference axis or the coordinate axis. So, let me choose the reference axis. Let me take it as point O, OX axis, OY axis. Whatever centroid I will be calculating is with respect to this axis. Okay. Next, after dividing, what is left out? We know the dimensions as well. What is the radius of this semicircle? If you observe this figure, the diameter is given. If this is the diameter of the semicircle, the radius of this semicircle will be 50 mm. Yes or no? So, component 1 is quadrant. So, let me name this O, A, B, C and D. Again, it is for my convenience. Next, this is quadrant A, O, B, component 1. What is the area of the quadrant of a circle? So, the area of semicircle is half of the area of the circle. The area of quadrant of a circle will be half of the area of the semicircle, that is pi r square by 4. It is pi r square by 2 will be equal to pi r square by 4 here. What is r equal to? This is the radius r, which is given as 100 mm. Again the same thing is given here as well, which is nothing but the radius 100 mm. See, do not get confused. The radius of this quadrant is 100, the radius of the quadrant is 100 here, but the radius of this semicircle is not 100, it is the diameter. You can make it out from the figure. Okay? So, where does the center of the quadrant lie? We have already calculated or derived, that is somewhere here. So, we have both x component and its y component. Okay. So, pi into r is 100 square by 4. That is equal to 7853.9 mm square. Next, what about its x component? X component of a quadrant of a circle is 4r by 3 pi. 4 into 100 by 3 pi. It is 42.44. And the y component is also equal to 4r by 3 pi, which is equal to 42.44 mm. So, this is the details of component 1, that is area 1 and x and y components of only the quadrant has been calculated. Next, component 2. So, component 2 is our semicircle. Semicircle O C B, and the radius is 50 mm. The radius is 50 mm, and also this is also nothing but the radius, which is equal to 50 mm. Please be careful while writing these values. And for a semicircular component, where does the centroid lie? We already know that it exactly lies along this line because it is symmetrical. So, there is no x component here because it is symmetrical. So, this will be only the y component. This I am writing only the individual component. Okay. So, area 2 is equal to, area of a semicircle is pi r square by 2, pi into 50 square by 2. See, what is the mistake that you are going to do is, if you do not take r is equal to 50 and put r is equal to 100 there, r is not 100 for this semicircle, it is 50. So, here you have r, here also you have r, but it is two different r's. So, for that let me write r1, 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 r1. Now, there is no question of getting confused. Now, this will be r2, r2, r2 and r2 square. Okay. Now, this is pi into 50 square by 2, and this is the part that is being removed out. So, minus sign, and again here minus sign. Pi r square by 2 is minus 3926.99 mm square, and its y component is equal to 4r2 by 3 pi, which is 4 into 50 by 3 pi. Clear? Component 1, component 2. Now, fill these data in the tabular form and then try to calculate the x bar and y bar. First component is the quadrant A, B, O. Area of this quadrant is 7853.98. Now x1 is equal to the centroid of this component 1 lies somewhere here. So, this is nothing but the x1, which is nothing but 4r by 3 pi, 4r1 by 3 pi, which we have already calculated, that is equal to 42.44 mm. And what about its y1? Measure it from OX axis, and this is the y1, which is also equal to 4r by 3 pi. That is equal to 42.44. Let me write R1 equals to 100 mm. Next, component 2, OCBD is the semicircle and radius is 50 mm. What about its area? It is minus 3926.99. Why minus? Because it is the part to be removed. And x2 is equal to, so for the second component we know the centroid lies somewhere here, and this is the distance that has to be measured. So if you look at this point, it is nothing but equal to the radius, that is the radius of this semicircle. So x2 is nothing but the semicircular component with respect to OY axis, which is equal to R2, which is 50 mm, and y2 is equal to 4r2 by 3 pi. So measure the same with respect to OX axis. This will be x2 and this will be y2. 4r by 3 pi is 21.22. So now substituting all these values to calculate x bar, a1 x1 plus a2 x2 divided by a1 plus a2, which is equal to a1 is 7853.98 into x1 42.44 plus a2 minus 3926.99 into x2 50 whole divided by 7853.98 plus of minus 3926.99. So after substituting and calculating the x bar value, you are going to get it as 34.88 mm. This is x bar. Similarly, y bar, a1 y1 plus a2 y2 divided by a1 plus a2, which is equal to 7853.98 into y1 42.44 plus minus 3926.99 into y2 21.22 whole divided by 7853.98 plus minus 3926.99. So after substituting a1, y1, a2, y2 and a1 and a2 in the formula of y bar, we get y bar is equal to 63.66 mm. So we have calculated the x bar and y bar values, and the last step will be g of x bar comma y bar is equal to 34.88 comma 63.66 mm. Now you need to locate this in the actual figure. So x is 34.88, 50, 34, okay, somewhere here, and y is 63. So this is 50, 63. So somewhere around this junction we can locate the location of G, x axis, y axis. So this point is the location of the centroid of given lamina of the, that is, shaded region. Okay. I hope you have understood this. Clear? Okay. Let us move on to the next problem then. Find the center of the shaded area shown in figure, and the figure is like this. So in this problem, as shown in figure, the question continues. As shown in figure, with respect to point O, they have specified a point, that is, point O is given. So this will be OX axis, this will be a YY axis, which is already given, and the dimensions are, this is 4 centimeters, this is 10 centimeters, this is 15 centimeter, and the radius of this semicircle is r equals to 5 centimeter, and the shaded region given here is this. So in this particular lamina, we need to cut a semicircular portion and try to find the location of the centroid. Clear? In this particular problem, they have specified the reference axis to be chosen. We do not have that liberty here. Or if this point O was not given in the question, we could have chosen the origin O according to our convenience, but in this problem they have clearly specified that you have to go with this point as O. So need to locate the centroid with respect to O only, okay, that is given O. Now let me divide this into number of known components. So let this be rectangle component number 1, let this triangle be component 2, and let this semicircle be component 3, whose area has to be removed out, that is, area should be written with a minus sign. Now writing component 1 details. Component 1, let me name it 10 centimeter, 15 centimeter, and this is A, B, F and O. Where does the centroid of this rectangle lie? We know it is exactly at center. So, this will be our x component, this will be our y component. Therefore, its area A1 is equal to 10 by 15, which is equal to 150 centimeter square, and its x component is half of 10, is 5 centimeter, and its y component is 15 by 2, which is 7.5 centimeter. Next, component 2. So, which is component 2? Triangle. O, F, H. So, for this triangle, we know where the centroid lies. It can be located at this point. Okay. So, its x and y components will be, this will be x, this will be, this will be x and this will be y. Now, writing its area, A2 is equal to half into base into height, that is 20 centimeter square. Its x component is 10 by 3, this is 3.33, and its y component is 4 by 3, which is 1.33 centimeter. See, what is the necessity of writing this step is, we have a clear picture about measuring the centroidal distance with respect to the referral axis. So, this is plotted only in order to make sure where exactly the centroid of the individual lamina lie or individual section lie. Okay. So, that will help you out to locate the centroid in this figure and measure with respect to the reference axis. This is component 2. Now, let us write the component 3. Component 3 is semicircle. C, E, F and D. What is the radius? 5 centimeter, 5 centimeter, 5 centimeter. So, in this component, the semicircle orientation is being changed. That is why the centroid of this semicircle lies, it will lie at a distance of, say, x. It is not y, it is x, because the orientation is changed. Y component of that is absent because it is symmetrical about the x axis. Now, write the area. A3 is equal to pi r square by 2, negative sign because it is the part to be removed, that is equal to minus pi into phi square by 2, minus 39.27 centimeter square is A3. Now, coming to its x component, which is 4r by 3 pi, which is 4 into 5 by 3 pi. So, these are the details of component 1, component 2 and component 3. See, these values are not the values to be taken in the table. These values give you a clear picture about the individual components centroid. By taking that as a hint, you can locate the centroid with respect to the referral axis given. That is why we are doing this step. Okay. So, these x and y components are only determined here in order to locate that here, and next using this you are going to locate that with respect to referral axis what is the x bar and y bar values. So, now let me write the table. Component, the next is an area, be careful, it is centimeters square, x bar in centimeter with respect to OX, y bar in centimeter with respect to OY axis. Coming to component 1, A, B, F, O. Rectangle, area is 10 by 15, 150 centimeter square. X bar, what about its x1 with respect to OX? So, center, this will be x bar and this will be its x1 component and this will be its y1. So, by looking at the figure and from the previous step we can easily say x1 is equal to 15 by 2 which is 7.5 centimeter and y1 is equal to, sorry, it is 10 by 2. X1 is 10 by 2, y1 is 15 by 2 which is 7.5 with respect to OX and OY axis. Okay. Now, coming to second component which is this triangle OFH. So, the area of this triangle is 20 centimeter square. X2 is equal to, you need to locate the centroid somewhere here. So, this is our x2, you are measuring with respect to OX, x2 is nothing but 10 by 3, 3.33 centimeters. Coming to y2, y2 is measured with respect to OY axis, sorry, it is OY and this is OX, OY and OX. So, with respect to OY we have calculated x2 or measured x2, with respect to OX measure y2. See, from this axis you need to measure what is y2. If you clearly observe, the axis OX axis and point y2 is below OX axis. So, if y is measured below the axis, the sign convention treated to be is negative. So, y2 is minus 4 by 3 which is equal to minus 1.33 centimeter star, because it is measured below the axis. And at last the component 3, that is semicircle CEFD, area of semicircle is minus 39.27 centimeter square with respect to OY axis. So, the centroid lies somewhere here. This is the value of x3, but you try to calculate it from the other end, that is 4r by 3 pi. So, what you need to do is total width is 10 centimeter minus 4r by 3 pi should be done in order to calculate or locate x3. So, x3 is equal to 10 minus 4 into 5 by 3 pi, which is equal to 7.878, and y3 is equal to, with respect to OX axis, this is nothing but y3. So, this is y3. What is this value? Equal to radius. Radius is 5 centimeter. Now, you have all the values to calculate x bar and y bar. So, x bar will be equal to a1 x1, a2 x2 plus a3 x3 whole divided by a1 plus a2 plus a3, which is equal to 150 into x1 is 5 plus 20 into 3.33 plus A3 is minus 39.27 into x3 7.878 whole divided by 150 plus 20 plus minus 39.27, which will be equal to 3.88 centimeters. So, this is x bar equals to. Similarly, let me calculate y bar. So, y bar is equal to a1 y1 plus a2 y2 plus a3 y3 whole divided by a1 plus a2 plus a3, and y1 is 7.5, y2 is minus 1.33, please be careful, and y3 is 5 whole divided by 150 plus 20 minus 39.27, which is equal to 6.9 centimeters. Now, we have obtained the values of x bar and y bar. Let us write the last step. Which is therefore g of x bar comma y bar is equal to 3.88 comma 6.9 centimeters. Now, you need to locate these values in the figure. So, x is 3.88, y 6.9. With respect to this axis 3.88. So, somewhere here this is 3.88, 6.9 somewhere here. So, this is our g of x bar comma y bar. X and x, this is y and y. So, this is how you try to locate the centroid of the given lamina of the or the shaded region. I hope it is clear. Okay.